What I was going to talk about was the electronic assessment methods that we're using in engineering. And in the presentation I'm going to give, I'm really not going to talk about the detailed implementation of how we've done this, but really the thought processes behind how we've approached doing this assessment, and also touching on some of the things that we've got rather wrong over the last 3 or 4 years, and where I think we're perhaps going to be going over the next year or two as we seek to improve our offerings to the students in this particular area. The rationale for electronic assessment was really threefold. The first one was really that we wanted to be able to give exam marks back to students more quickly. And every academic on campus knows that one of the worst things that you can have is a very large pile of exam scripts to mark, which may take you a week, maybe even 2 weeks to mark, and all the time you're conscious that the students are really wanting to have the marks back. The way we've implemented this, essentially, the students do their electronic assessment, their exam, in this way, and then they get the marks immediately. So they know as they leave the room how well, or hopefully how well they've done, and we're also able to see how well the class has done and think about responses to that. So, for instance, if sections haven't been done particularly well, thinking about introducing or reintroducing the material to the students. The second issue really is then more consistent marking, because again, as you come to higher and higher numbers of students, making sure that you've marked the 200th exam script exactly the same way as the first exam script becomes more and more difficult. And as you can put procedures in place which hopefully catch any major errors in doing that. But having electronic marking means that you're absolutely certain that everyone has been marked the same for the same answer throughout, and that's, I think, a very good thing. The last consideration was really that the staff time then really go by adopting the electronic assessment, really goes from the marking, which is essentially a huge amount of time with not very much to show for it at the end apart from some marks, to teaching and to thinking about setting assessment, so thinking about how best to get the learning outcomes or testing the learning outcomes that they're met, and how to really sort of ensure that the weak students are given something to get hold of, and the strongest students are given something that's really going to challenge them. And that's sort of the reason that we've adopted this this approach. Oops, let me just click on that one. Okay, just before I sort of go on to thinking about the details, I'll tell you about how we've ended up, the structure of our modules in doing all of this, because I think it sort of shows how often we're running these and the sorts of marks and things that we're actually giving the students for this. So in our first year, we essentially have 3 30-credit modules, which are sort of standard lecture, largely lecture-based modules. We also have there's 3 of those, and then the remaining 30 credits are in labs and other continuous assessment-based material. But in these 30-credit modules, we actually have 4 sets of assessment. So 1 in week 7, so basically our first years arrive in Leicester, and then 7 weeks later we give them their first test, which really sort of sets the scene for everything else in the degree programme. And that first electronic assessment is worth 10% of the marks. And deciding what level to give these assessments is quite a crucial question, because if you don't give them enough marks, the students won't take them seriously. If you give them too many marks, particularly in week 7, you don't want people failing modules after 7 weeks, or not being able to redeem themselves after that sort of time. So 10% was sort of the level that we arrived at, which basically gave the students a good incentive to take it seriously, and but didn't leave them in a situation where they couldn't recover from that if they'd done very badly. So we have 1 in week 7, we have 1 in week 12 in the normal January exam period, and 1 in week 18, so all worth 10% of the module. And then in the normal May-June exam period, we also have, at the end of all of this, a traditional written examination, which is worth 70%. In the second year, we do it slightly differently. We decided that we didn't need quite so many assessment points for the second years because they're old, mostly old hands by this stage, even our direct entrance. So we sort of consolidated that 30% of the electronic assessment all into one single test in the January exam period. And then again, in the written exam, they have a written exam in May and June. There is one exception to this, and this happens to be my module, because we're sort of testing out new ways of going with this, and we've actually removed the written exam. So this module is entirely electronically assessed, with half the module in January and then half the module marks in May and June. Now you might think this is a brave way of going about it, and we did seriously consider this, but after last year, oops, sorry, wrong. Let's just go on that button. One of the things we looked at was what happened to the marks as we introduced these different ways of assessing the students. And on the y-axis here, we've basically got the mean electronic assessment mark, which are binned in, as in this case, I think 5 percentage point wide bins of exam marks. So we've effectively plotted for each student how well they've done in the Blackboard electronic assessment compared to how well they've done in the exam. Now, the first nice thing about this is at least the slope's in the right direction. That's a very good thing. So basically, good students who've done well in the exam will tend to do well in the Blackboard assessment, and the weaker students in the exams also tend to do worse in the electronic assessments as well. The interesting thing I think that we found in this particular graph is that it has changed the slope, and here what we found is that the weaker students actually do better in the electronic assessment than they do in a conventional written exams that we set, and the stronger students do a little bit worse. And there are a number of reasons we think this is that might explain this. One of which is at the moment virtually all of our Blackboard assessment doesn't have choice associated with it. At traditional written exams, typically you might set 5 questions, you ask the students to do 3 of them, and you mark on that basis. The Blackboard assessment, we ask them to do all the questions. And this changes the students' revision pattern, because instead of question spotting and the sorts of techniques that they often use in this, they have to revise everything. And this, we think, this gives the weaker students more incentive to revise more, so they end up with slightly better marks. And for the stronger students, because they've got to do everything, they can't be excellent at everything, and therefore they just fall down a little bit at the end. We're just beginning to look into the effect of choice, because we've run choice on this more experimental module this year. We've got some results from that now from week 12, and we're just having a look at those. And we think we can see a clear effect of allowing choice into these tests. The other nice thing is I've written the mean marks on there as well, so we can see actually the electronic assessments the students do very slightly better, almost the same average, which gives us some confidence that we're not setting these too hard or too easy, but just slightly better, which is obviously, I think, a good thing. So let's have a think about how we set these. And I think that the biggest point, the key point here that I would like to start with before we go into the details, that is electronic assessment is not equal to multiple choice. Okay, multiple choice may figure, but I think a lot of the time when we've been talking about this, people say, oh, you're setting multiple choice exams. It doesn't have to be like that. Blackboard gives you a much bigger palette of question types than multiple choice. And we also know, because there's certainly people who've been looking at this for decades, that setting multiple choice questions is actually a really difficult problem, because you have to set questions which have realistically possible answers across a wide range, so that the students don't end up saying, well, okay, those 3 are nonsense, it must be one of those 2, and then they've got a 50% chance of guessing the right answer. So that's the first thing. The second thing we did was when we actually went back to the written papers and actually said, well, how do we actually set these papers? The short answer was, of course, we set questions which we've always set. And if we, when I first started in the department, my colleague who just retired a year after I joined, he bequeathed me a set of exam papers going back to 1963. Which was very nice. It was interesting. In fact, I've had to throw them away now because I didn't have any room in my office. But it was interesting seeing question development over that sort of 30-odd year period, and also how some things have stayed very similar. And I think, you know, sometimes you set questions in a particular way because that's what we've always done. And I think one of the things this has done for us within the department is made us think about this again. But a typical written question is something like, in engineering, other subjects will probably vary, particularly in sort of arts, humanities areas, but I think this is probably a fairly typical style in science and engineering at least. You know, there's a 40% part of the question, roughly 40% part of the question, which is bookwork. So things like derivations of equations, definitions of terms and things like this. So it's essentially, have you turned up to the lectures? Have you learnt anything at all during the time you've been here? There's a second part to that then, which is a sort of calculation design, which is also worth about typically roughly 40%. This is, can you use what you've derived, the equations and so on, and can you put some numbers into the equations? Can you design something? Can you work out, for instance, how much power this particular system needs, or whatever the question is addressing? And then there's this last 20%, the sting in the tail, or the discussion part of the question, which, you know, you've derived something, you've got this result, what does it mean, how might you change the design, how could you improve the performance? So a much more open-ended type of question, and perhaps more similar to the sorts of questions that are asked in other departments as well, this sort of small essay, small sort of discussion question. So how do we do these sorts of things in Blackboard? The nice thing is that the first two are quite easy, or I think they are, but the last one is probably a little bit harder, and I'm not sure we've quite mastered that yet, but we're getting there with the sorts of things we're asking. This is a bookwork type of question, and I've sort of drawn it from Blackboard. I'm not really going to show anything in detail sort of how we've implemented these things in Blackboard, because that's really implementation dependent. We're sort of looking at the broad level here. Doesn't really matter what the content of this question is either, but essentially it's testing something. What do you know? And the key thing here is it's a multiple answer question. So we asked them about waveguide modes in this particular case. This is from one of my tests. I teach this in our second year. But the key thing is here we've got 5 statements here, and we're asking the students to say, okay, which of these is true? It's the sort of thing that you would ask in a written question, as saying, okay, you know, what 3 assumptions do you make in deriving this equation? What 3 things, or what things are important about this particular subject? And the first thing is that we don't tell them how many answers are correct. So they have to decide which out of these 5 are correct. The second thing is Blackboard allows you to add partial credit here, which means that if the students get the whole kind of question right, obviously they get all the marks. If they only get, say, 2 of the answers, that there are 3 correct ones in this particular question, if they only get 2 of them, then provided they don't get a wrong answer as well, the Blackboard algorithm that they actually use is quite complex. There's a short paper online about this, and I read through it. I'm not sure I was any the wiser after reading through it, but well, I think me and a colleague, we vaguely got an idea of what was going on. But essentially, if they get 2 right and nothing wrong, then they'll get 2/3 of the marks. If they get 1 right and nothing wrong, then they'll get 1/3 of the marks. So the students can get they can get marks for knowing a bit, which is obviously quite useful, because that's the sort of thing we ought to be rewarding for students if they've got, say, basic knowledge in the sort of QAA parlance with this. So that's one style of question. So we can do bookwork questions quite nicely. Calculations are also equally easy. We can include diagrams. In fact, with bookwork type questions, you can include pictures, you can include diagrams. One of my colleagues, facetiously, in one of his early drafts of one of the Blackboard tests, had a picture which was taken of him at a conference with a number of other colleagues from other universities. And the question was, can you identify in the picture which is the lecturer? And they could click on which one it was actually was. We thought, giving 2 marks for the students for turning up and seeing someone might actually be quite a nice thing. That was removed from the final one, needless to say, but it was a nice approach. So the sorts of calculations we can get, again, the details aren't really important here, but we've got a diagram. There's a relatively straightforward calculation with this, I'll assure you, so for students ought to get this sort of question right. And the nice thing is okay, we've got an answer which is 5 volts in this particular instance, but we're able to stick a little range around this. So essentially, as I've set it up here, the right answer would be 4.95 to 5.05. Now in this particular question, that's probably not entirely necessary. But in some questions where students might make very slightly different assumptions, say about the value of pi, the value of the speed of light, or various other physical constants, it allows them to have a little bit of leeway in getting the right answer. You know they've done the right method, but they haven't quite got the right answer because the rounding errors in the calculator and things like this. So it allows you to do that. The other important thing with calculation type questions is that typically in an exam where a calculation is 40% of the marks, if you ask that as a single Blackboard question, you're just really setting the students up to fail, because okay, clearly the best students are usually able to go all the way through a question and get the right answer. That's more often not the case than is the case with these sorts of calculations. So you expect students to get a bit wrong somewhere along the line. So what you have to do is break up these longer calculations into smaller parts, so that the students can say, this 40% part in a written paper, you might divide up into 4 or 8 questions, and the students then can get the first 3 or 4 right, and then the other one's wrong, and they've still got some credit for that. You're not really sort of saying, okay, well, you've done nothing, and therefore you'll get 0. This is an area which the students are very aware of. This was an area which we had a lot of feedback from them, largely negative feedback in the early years, where they felt that we weren't giving them enough marks for working in these questions. So we listened, we took some of this on board, and we've sort of tried to address this over the last few years. And they were quite right, I think, certainly in some of the tests we'd set, we were asking rather too much for the marks available. The discussion type questions, this is quite hard. And I think anybody who wants to, for instance, one of the things you certainly can't have automated marking on is an essay, which is unfortunate for me. I set essay questions in one of my 4th year modules where I talk about the history of engineering, and there's no way I could make that sort of assessment into a Blackboard or electronic assessment at all. So there are some things you can't do, and I think we have to accept that. One of the problems that we have with this, of course, is that discussion type questions are open-ended questions. So, and assessment of this type, I mean, this is an example of one way we've tried to sort of do this. This is a matching style of question that Blackboard allows you to do. Essentially, you've got four different statements here, and then you have to choose which ending of each statement is that it matches up. So essentially, you're completing the sentence, but over four different questions in this particular instance. Again, there's partial credit, so if they get one right, they'll get some of the marks and so on. The problem is this isn't open. This is closed because you're telling them the answer or the selection of answers beforehand. So this is something we're still trying to think about how to do this well, and we're getting there, but I'm not quite sure we're there yet. One of the ways we can do this sort of is to actually have far more answers down here than just 5. So you have 10 or 15, and make them really think about sort of which ones are right, have ones which are very close, semantically very similar, or sort of technically very similar, which really stretches them in this. So even though you're giving them a choice of answers, they've got to think about how to do it. I say we're making progress on that, we're still learning. The last slide then is sort of other considerations, and so sort of really addressing some of the things that we've got wrong with this. And the first, and I think absolutely fundamental thing to getting this right, is student preparation and expectations. You have to tell the students what to expect. You have to give them practice quizzes. You have to really address the things that are going to worry them. What happens if my computer crashes? What happens if I accidentally submit my test before the end, which we've had. In fact, that happened in January to my test. It's taken us a while to work out how we actually deal with this. The first year we probably didn't deal with this very well. I think we deal with at least the things that we've come across much better than we did. But it's this sort of thing, you know, because it's complicated for the students. I mean, in a written exam, they write it down. Nothing's going to happen to that piece of paper. It's not going to spontaneously catch fire. Or we're not going to lose it. Fingers crossed. I don't think we've ever lost a written exam paper yet. But with a computer, it's far more ephemeral. There's far more things, the worries for the students. So you have to address their concerns with that. And I think we've got better with at least some of that. We also had to think very carefully about how we actually presented the presentations, the assessments themselves. So I mean, these are formally invigilated, so they're held under exam conditions. Again, we had a long discussion and argument in the department as to whether we were going to leave this as a go and do this in your own time, or even set a time that you can do it anywhere on campus. We do allow first year is open book. Second year is closed book. Again, one of the reasons we do that for the first year is because we're asking them to do an assessment after 7 weeks. You know, we know that they haven't fully assimilated the material at that point, so we've got to allow them to take the books and their notes into the assessments. All the questions in one scrollable test. We can make exceptions for students who need this presented in a different way. We were originally advised that we needed to present questions on 1 page at a time, and subsequent to that we had some focus groups with some of our students, and this was something they really hated because they couldn't scroll to the questions they wanted to do. Good exam technique. You know, I was always taught, go and do the questions you can do first, and then come back to the other ones later on. And if you don't allow them to do that, you're suddenly cutting them off from this lessons that they've learned elsewhere. Other things like we don't randomise the question order, so all the students get the same test. We don't randomise the order of answers within the questions, or indeed change the answers, so all the students get the same test. We don't give them a choice, as I mentioned earlier. And the last thing, I guess, is we do give them the final mark, but we don't give them the results for individual answers. Mainly because at the moment we recycle significant portions of the assessments from one year to the next. There is some question churn because we obviously sort of change some of these from year to year. The reason we are recycling the tests is that they are time consuming. A written exam would probably take me, on a module I've done for a long time, would probably take me between an afternoon and a day. The Blackboard assessment, the equivalent one that I did for January, took me 3 days. So it's a lot more effort in the front side of things if we want to be able to reuse that. Once we get to the point where if the university does go down the route of giving students full feedback on exams, we're going to have to revisit this, and we'll see what the outcome of that is in due course. But there you go. Okay, thank you very much.
Thank you,
The voice
Alan, if you'd like to say, because actually a couple of questions in the question one. So you answered one of them about the invigilation, but someone's actually asked, well, how many students are undertaking the exams at the same time?
Okay. In our first year assessment, we have 200 students, and this is at the moment a significant problem across the university because there are no computer rooms which hold 200 students. So, for instance, we've actually been running assessments this week because we're in week 18, and I think we've managed to get all of the assessments for the first year into 4 rooms. Now, this has a cost in terms of invigilation time. It also has a cost because you'll spread the students out. It means if there's a problem, it takes time to disseminate the problem amongst all of the students, so that there is an issue there. The interesting thing is week 7 and week 18, we're on our own. We have to do this within the department because the exams office, I think probably quite rightly, say these aren't in the exam times, therefore we're not going to look after them. Weeks 12 and whichever the May-June period is, then the exams office look after these, so they're just treated as normal exams. So the poor people in the exams office bear the brunt of the organisation during those during that period. So there is a cost to the. I mean, in fact, one of the things we actually also use, we use PhD students for invigilation in the week 7 and week 18 tests, so that we're not committing. I think there's usually we're going for 2 academics and 2 PhD students for invigilation for typically 50 or 60 students.
That's pretty fun. So if they're all undertaking in a computer lab, how are you? Is part of the invigilation ensuring they're not going off and googling answers?
Yeah, absolutely. I mean, it's they're under normal exam conditions, it's hard enough. I mean, having the written exams in the last set, I think I've invigilated 2 exams and found someone cheating in both of them in the written papers. For online tests, obviously you've got this additional problem because you've just got so many ways that they can sort of break out and look for the answers. The interesting thing is that for a lot of questions, it would probably take them longer to Google the answer than it would to do if they actually knew the material and knew what the answer is. And certainly for the calculations, even if they're given the method, by the time they've gone off and found it, come back, and worked through and got the answer, they've done one question where they should probably have done 3 or 4 in that time as well. But we do wander around. We wander around, we look at the screens, we check very carefully that they're not going out of this. At one point, the university was considering investing in some software which will then actually tie them into Internet Explorer, and if they click out, their test stops. And we've reopened negotiations with the university as to sort of saying, well, we'd really rather like this if you could provide it. It also stops screen capture and things like this as well, which is useful. But it's not trivial, and it's quite a burden, the administration. But I actually did a cost-benefit analysis on the second year test, and I think we found that we saved 200 hours of marking or thereabouts, and we expended about 130 hours on invigilation and all the rest of the sorts of things. So there was a clear benefit, but it wasn't as high as we were perhaps hoping in the first instance. If we get this huge computer room that, again, we've been promised, or possibly, which will hold 200 or 300 students, this will be great. All of a sudden,